All right, what we want to look at today is the phases of matter, which we said are the solid, the liquid, and the gas phase. And what we want to look at is the energy required to move from one phase to the other. Now, we said that one way we can think about energy is through the temperature. So as we increase the temperature, we're increasing the average energy of the molecules in our system. So what we can think about is we can think about having our energy go as our temperature. And so we can put temperature here and we can put our energy here. So what we want to do is we want to look at, as we ramp up as we increase the energy, what happens with the temperature. So let's assume that we start down here with some solid. Let's assume we're starting with ice, and we have some cold ice. And as we dump temperature if we dump energy into our solid block of ice, the temperature will go up until it reaches what? Until it reaches 0 degrees Celsius. Then at 0 degrees Celsius, what will happen is, as we continue to dump energy in, the temperature is going to remain constant. And this is because what happens is, when we reach 0 degrees Celsius, so at 0 degrees Celsius, as we continue to dump this energy in, we're breaking apart the little bonds in the solid and letting them, or we're breaking apart the rigidness of the lattice in the solid, and we're converting it into a liquid state. So as we add our energy, we don't change temperature, but we're introducing energy to remove the lattice state of the solid and put it into a liquid state. Then after we've added enough energy and we've converted the entire solid into a liquid, we then continue to add energy and our temperature will continue to rise. Now the temperature will rise again if we're using water. It will rise to 100 degrees C. Then at 100 degrees C, what happens is we go and we start converting the liquid into a gas state. So here, as then we continue to add energy, what happens is we have our temperature stays the same, and what we're doing is we are now dissociating from the liquid into the gas. So we're breaking apart any of the bonds that held the liquid together, and we're converting the molecules into a gas. And we continue to add the energy until all of our liquids converted to gas. And then after that, we continue to add energy, and our temperature just continues to rise off the chart. So the idea is that when we have our three phases, if we started in a solid phase, as we add energy, the temperature would go up as we add energy till we reach 0 degrees C for, let's say, ice. Then at 0 degrees C, we start to undo the lattice structure of the solid. So the solid's like rigidly held in place, and then as we add the energy in at 0, we start to break it apart, and the molecules are allowed to move as a liquid. And we have to dump enough energy in so the whole solid is now converted to liquid. Then, when we go and we continue to add energy, as we add more energy, we just raise the temperature of our system to 100. But once our liquid water is at 100, we then go through another phase change where we now are converting all of our water into gas. Once all of our water converts to gas, we then continue to add energy, and all of our gas just has its temperature increase until we stop adding more energy. But these two regions here and here, these places where we convert, these are called our phase changes. And this first one, we can either go, in the first phase change, we can either go from solid to a liquid if we're heating. If we're taking energy out and coming backwards, we go from a liquid to a solid. So it only depends on which way we go through the phase change. If we're adding energy, we go solid to liquid. If we take energy out, what are we doing? We're taking the liquid and we're slowly locking those bonds into place to make them a solid again. Now on the other side, what we have is we are going from a liquid to a gas if we add energy. Or if we take energy out, we go from a gas to a liquid. And when we do the first one down here, this is called the heat of, add or take energy out is the heat of fusion or and this one over here is the heat of vaporization. So this is the idea. We can, by adding energy into our system or taking energy out, we go, whenever we want to go from a solid to a liquid or a liquid to a gas or vice versa, we either have to add or remove energy to move from during what we call a phase change, where we want to go from one state of matter to another.